So, good morning, students. Welcome to the session. My name is Vijay Sri, Senior Lecturer in Physics, GPT, Hyderabad. So, what is wave motion? Wave motion is the transfer of energy and momentum from one point of the medium to another point of the medium. So, wave motion. What is wave motion? Wave motion is the transfer of energy and momentum from one point of the medium to the other point of the medium without actual transport of matter between 2 points. Wave motion is classified into 3 different ways. The medium of propagation, the dimensions of which a wave propagate energy, that energy transfer. So, for example, look at the picture. Waves forms in a ripple tank, periodic motion of a simple pendulum, etc. are the examples of the. So, classification of wave motion based on the medium of propagation. So, waves are two types, mechanical waves and non-mechanical waves. So, in mechanical waves, medium is required. Non-mechanical waves, medium does not require. So, mechanical waves based on vibration of particle of the medium, based on the energy transfer. So, based on vibration of a particle of the medium is transverse waves, longitudinal waves. Based on energy transfer is standing waves, progressive waves. So non-mechanical waves means medium does not require. So this is the classification of wave motion based on the medium of propagation. So number of dimensions a wave propagates energy, one-dimensional wave, two-dimensional wave, and three-dimensional wave. For example, one-dimensional wave produced in a stretched string, two-dimensional ripples on water, three-dimensional waves, propagation of light and sound waves. So, based on transfer of energy, standing waves remain confined to a region without any transfer of energy, and momentum, whereas the progressive waves transfer energy and momentum between the particles of the medium. So, based on the transfer of energy, standing waves and progressive waves are there. So, mechanical waves and non-mechanical waves. Waves that require a medium for their propagation are called mechanical waves or elastic waves. What is a mechanical wave? Waves that require a medium for their propagation are called mechanical waves or elastic waves. The particles of the medium execute periodic motion between about a mean position when the wave propagates through the medium. For example, waves on a string, a mechanical wave is produced due to a disturbance at a point in a medium. The disturbance particle interacts with the neighboring particle and its energy is handed over to the next particle due to the inertia of the medium. So the disturbed particle return to the equilibrium position due to the elasticity of the medium, called the mechanical waves. What is mechanical wave? Waves that require a medium for their propagation are called mechanical waves or elastic waves. So the particles of the medium execute periodic motion. So next, properties of a medium for mechanical wave propagation are: the medium must possess inertia so that its particle can store kinetic energy. The medium must possess elasticity, the medium frictional force between the particles of the medium, the minimum frictional force between the particles of the medium. So these are the properties of a medium for mechanical wave propagation. So what are the properties of medium for mechanical wave propagation? The medium must possess inertia so that its particle can store kinetic energy. The medium must possess elasticity, the minimum frictional force between the particles of the medium. So what are non-mechanical waves? Waves which do not require a medium for their propagation are called non-mechanical waves. So what is non-mechanical wave? A wave which do not require a medium for their propagation is called a non-mechanical wave. So these types of waves can propagate through a vacuum also. These are transverse in nature. For example, electromagnetic waves and matter waves. So these are the two types of waves. Mechanical waves are two types. Mechanical waves and non-mechanical waves. Waves are two types. Mechanical waves require a medium for their propagation is called mechanical waves. Waves do not require a medium for their propagation are called non-mechanical waves. So longitudinal wave motion. The particles of the medium vibrate about their equilibrium position in a direction parallel to the direction of propagation of a wave is called a longitudinal waves. So what is in a longitudinal wave? The particles displacement is parallel to the direction of the wave. Propagation of wave is called longitudinal wave. It's called longitudinal. Longitudinal waves require a medium which only elasticity of bulk volume, that is bulk modulus, for its propagation. In this type of wave motion, the waves travel through a medium in the form of compressions and rarefactions. So look at the picture, longitudinal wave on a stretched spring. The region of high pressure is called compression and the region of low pressure is called rarefaction. For example, sound waves in the tube. So transverse wave motion. The particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave. What is transverse wave motion? So the transverse wave in transverse wave motion, the particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave. The region of maximum upward displacement is called the crest region. Of maximum downward displacement is called trough. So transverse wave motion occurs only through a medium which has a rigidity modulus or shape conservation. For example, string waves. So look at the picture. So periodic wave motion. If the disturbance is continuous and is periodic in nature, then the wave produced is termed as a periodic wave. What is a periodic wave? If the disturbance is continuous and is periodic in nature, then the wave produced is termed as a periodic wave. The periodic wave that is varying sinusoidally is called a sinusoidal periodic wave. The particles of the medium execute simple harmonic motion when a sinusoidal periodic wave passes through the medium. So what are the characteristics of wave motion? In wave motion, the disturbance travels through the medium due to repeated periodic oscillations of the particles of the medium about their mean position or equilibrium position. So in wave motion, so the disturbance travels through the medium due to repeated periodic oscillations of the particles of the medium about their mean position or equilibrium position. So energy and momentum are transferred from one point to another another point without any actual transfer of the particles of the medium. So energy and momentum are transferred from one point to another without any actual transfer of the particles of the medium. So there is a regular phase difference between the particles of the medium because each particle receives disturbance little later than its preceding particle. So the velocity with which the wave travels is different from the velocity of the particles with which they vibrate about their mean or equilibrium position. For a given medium, the velocity of the wave motion remains constant while the particle velocity changes continuously during its vibration about their equilibrium position. The velocity of the particle is maximum at the mean position and zeros at the extreme positions. So these are the characteristics of wave motions. So once again I repeat it. In wave motion, the disturbance travels through the medium due to repeated periodic oscillations of the particle of the medium about their mean position or equilibrium position. Energy and momentum are transferred from one point to another without any actual transfer of the particles of the medium. So there is a regular phase difference between the particles of the medium between each particle receives disturbance little later than its preceding particle. So the velocity with which wave travels is different from the velocity of the particles with which they vibrate about their mean position or equilibrium position. For a given medium, the velocity of the wave motion remains constant while the particle of velocity changes continuously during its vibration about their equilibrium position. So the velocity of the particle is maximum at the mean position and zeros at the extreme position. So sound. Sound is one of the forms of energy which stimulates our sense of hearing. Sound is one type of energy which stimulates our sense of hearing. The man enters into the world by making sound, that is cry. The main use of sound is communication, not only among human beings but also among most of living beings. The male cuckoo bird produces melodious sound in autumn, of course, not to entertain us, but to attract the female cuckoo. A phone call from our friend alerts us with melodious ringtones in our mobile phones. The sound from a ringing bell of our college indicates the schedule of working hours. In this way, sound has an important role in our life. Some sounds will be pleasant and some will be unpleasant, that results in noise pollution, which became a major hazardous problems to the human comfort of this. So next, propagation of sound. So what is sound? Sound is one form of energy which stimulates the sense of hearing. Which bodies produces sound? Vibrating bodies produces sound. So the source of sound is a vibrating body. Sometimes we cannot hear the sound produced by the vibrating body. So actually, what is the audible range of sound? 20 hertz to 20,000 hertz. 20 hertz, less than 20 hertz are called infrasonics, and sounds frequency greater than 20,000 are called ultrasonics. Hence, the source of every sound that is heard or unheard is a vibrating body. Conversely, every sounding body is in vibrating condition that may be seen or unseen. So, how to propagate sound? So, the vibrations of sounds produced by the source travels through the medium and reaches the ear. The vibrations of sound produced by the source travels through the medium and reaches the ear. Then the eardrum vibrates accordingly and causes the sensation of hearing. Sounds propagates as a wave. Sound waves are categorized as mechanical waves, which require a material medium to propagate. Sound cannot travel in vacuum. So, sound travels in the form of wave. It needs a mechanical medium. So, sound waves are called mechanical waves. What is a wave? The disturbance created in a medium by the repeating periodic motion of the particle of the medium is called wave. What is wave? The disturbance created in a medium by the repeated periodic motion of the particles of the medium is called wave. So, wave motion, thus transportation of the disturbance from one place to another place in the medium is called wave motion. So, what is a wave motion? The transportation of the disturbance from one place to another place in the medium is called wave motion. So, wave motion is of two types, longitudinal wave motion and transverse wave motion. The wave motion in which the particles of the medium vibrate in a direction parallel to the direction of propagation of the wave is called longitudinal wave motion. So the longitudinal wave, the particle displacement is parallel to the direction of wave propagation, or the wave motion in which the particles of the medium vibrate in a direction parallel to the direction of propagation of the wave is called longitudinal wave motion. So vibration of the particles is parallel to the propagation of the wave is called longitudinal. For example, sound waves in air. Transverse wave motion. The wave motion in which the particles of the medium vibrate in a direction vibrates in a direction perpendicular to the direction of propagation of the wave is called transverse wave motion. So what is transverse wave motion? The wave motion in which the particles of the medium vibrate in a direction perpendicular to the direction of propagation of the wave is called transverse wave motion. Example, water waves. So, what is wave? Wave means disturbance created in a medium by repeated periodic motion of the particle of the medium is called wave. So, what is wave motion? The transportation of disturbance from one place to another place in the medium is called wave motion. So, wave motion are two types, longitudinal and transverse. What is longitudinal? In the wave motion, the particles of the medium vibrate parallel to the propagation of the wave. Is called longitudinal. In transverse phase, the particles displacement is perpendicular to the direction of wave propagation. So, sound waves in air is the example of longitudinal waves. Water waves are the examples of the transverse waves. So, what are the differences between longitudinal and transverse waves? So, longitudinal wave. The vibrating particle of the medium moves in the same direction of the wave, or the vibration of the particles of the medium moves parallel to the wave propagation. The vibrating transverse. The vibrating particles of the medium is moving perpendicular to the direction of wave, or vibrating particles of the medium is perpendicular to the direction of the wave propagation. So it acts in one dimension. Compressions and rarefactions formed. One compression and one rarefaction is called one wave. It acts in two dimensions. Crests and troughs are formed. One crest and one trough are called one wave. The wave cannot be polarized or aligned. The wave can be polarized or aligned. This wave can be produced in any medium such as gas, liquid or solid. This wave can be produced in solid and liquid surfaces. The earthquakes, P wave is an example. Earthquakes, S wave is an example. So P wave means primary wave, S means secondary wave. So these are the differences between longitudinal and transverse wave. So propagation of sound in air, consider a vibrating tuning fork. When the prongs move towards right, a compression is produced next to the prong as the compressed layer moves forward, it compresses the next layers to the right. When the prongs move to the left, it leaves a partial vacuum to the right, produces a rarefaction. As a result, air from the right rushes to fill the low pressure region and the position of the rarefaction also moves towards the right during the next compression. Thus, the compressions and rarefactions are produced alternately and advance to the right with constant velocity. These compressions and rarefactions follow one another as the prong vibrates and reach the ear, and the eardrum vibrates with the same frequency and causes the sensation of sound similar to the sound. Some important terminologies in progressive wave motion. So amplitude, sound is a progressive wave. So amplitude, the amplitude of a wave is the maximum displacement of any particle of a medium from its mean equilibrium position or mean position. What is amplitude? The amplitude of a wave is the maximum displacement of any particle of the medium from its equilibrium position. What is period? That means time period. Time period of the wave is the time taken by any particle of the medium to complete one vibration during a period. That is called time period. Time period denoted capital T, amplitude A. Wavelength. Wavelength is equal to the distance between two consecutive particles of the medium which are in the same state of vibration. It is equal to the distance traveled by the wave by its time period. So wavelength represents with the letter lambda. Frequency. It is the number of vibrations made per second by any particle of the medium or reciprocal of the time period is called frequency. What is wave velocity? It is the distance traveled by the wave in 1 second. So lambda by t is called the wave velocity. So these are the important terms we used in wave motion. Length is the distance traveled by the wave during the time of a particle of the medium completes one vibration. What is wavelength? Wavelength is the distance traveled by the wave during the time of a particle of the medium completes one vibration. So therefore, if lambda is the wavelength and t is the time period, then the wave travels a distance lambda and time t. Hence, wave velocity is equal to distance by time. So we know that speed is equal to distance by time, so that is equal to lambda by t. Here lambda is the wavelength of the sound. It is the distance traveled by the sound wave in one time period of the wave. V is equal to lambda by t. Lambda is equal lambda into 1 by t. But 1 by t is equal to frequency, that is equal to nu. So V is equal lambda nu. So speed is equal wavelength into frequency, or wave velocity is equal wavelength into frequency. V is equal to nu lambda is the relation between frequency, wavelength and velocity of the wave. A form of a wave in which the profile of R of the wave does not move through the medium but remains stationary in a medium is called stationary wave. So what is a stationary wave? A form of a wave in which the profile of the wave does not move through the medium but remains stationary in a medium is called stationary wave. Sometimes it is called standing waves also. Stationary wave is formed in a medium when a traveling wave is reflected back along its own path. In stationary wave, there are points at which the displacement is zero. These points are called nodes. Points of maximum displacement are called antinodes. So the distance between a node and its neighboring antinode is 1/4 of the wavelength, that is lambda by 4. In a stationary wave, all the points along the wave have different amplitudes and the points between successive nodes are in phase. So what is a stationary wave? Stationary waves are produced by superposition of two progressive waves of equal amplitude and frequency traveling with the same speed in opposite directions. So how do stationary waves form? Stationary waves are produced by superposition of two progressive waves of equal amplitude and frequency traveling with the same speed in opposite directions. So nodes, zero displacement is called antinode and maximum displacement is called node. The distance between node and antinode is lambda by 4. So the successive distance between two antinodes or two nodes is called lambda by 2. So properties of a stationary wave. Stationary waves have nodes where there is no displacement at any time. In between the nodes are positions called antinodes where the displacement has maximum amplitude. So the waveform in a stationary wave does not move through medium. Energy is not carried away from the source. The amplitude of a stationary wave varies from 0 at a node to maximum at an antinode and depends on position along the wave. So vibration of a particle in a stationary wave, look at the picture. At time is equal to 0, all particles are at rest because the particles reach their maximum displacement. At t is equal 1 by 4, that means time period by 4th, particles A, E and I are at rest because they are the nodes. Particles B, C and D are moving downward. They vibrate in phase but with different amplitude. Particles F, G, H are moving upward. They vibrate in phase but with different amplitude. So musical sound and noise. Musical sound. The sound that is pleasant to hear is called musical sound. What is musical sound? The sound that is pleasant to hear is called musical sound. In musical sound, the sound pulses follows rapidly, one after another at regular intervals, without any sudden change in loudness. The wave nature of musical sound is irregular. So, wave nature of musical sound is in regular shape. So, what are the examples? Sounds from musical instruments like sitar, guitar, etc. Sound produced by electronic keyboard, harmonium, etc. are the examples of musical sounds. So, noise. The sound that is unpleasant to hear is called noise. Noise produces jogging effect or displeasing effect on the ear. In noise, the sound pulses succeeds at regular intervals of time and there is sudden change in loudness. The wave nature of noise is irregular. The wave nature of noise is irregular. So examples, sound produced by crackers, sound produced by hitting a nail with a hammer, sound produced by automobiles, locomotives, aircrafts, etc. are the examples of noise. So next, differences between musical sound and noise. Sounds can be roughly divided into categories, musical sound and noise. So musical sound is pleasing effect on the ear and unpleasing effect is displeasing effect to the ear is called noise. So regularity, continuity and rapidity make a musical sounds different from a noise. The distinction between music and noise is not very sharp, it is subjective. So musical sound, it is pleasant, smooth and agreeable to the ear. It is harsh, discordant and displeasing to the ear. It is produced by the vibrations which are periodic is called musical sound. It is produced by an irregular succession of disturbances is called noise. All the component waves are similar without any sudden change in their wavelength and amplitude. In the musical sounds, the component wave changes their character suddenly and they are of shorter duration. In noise, the sound level is low, the sound level is high. So wave nature is regular in regular shape. In musical sounds, it is irregular in shape. So generally, sound waves from musical instruments like veena, guitar, and harmonium, sound waves from thunder, crackers, trucks, and etc. are the noise. So these are the differences between musical sound and noise. So let us start a small quiz. What type of wave is pictured? So look at the picture. Longitudinal, light, standing, transverse. Which one is correct? So longitudinal is the correct. Sound is a type of dash energy, radiant, electrical, mechanical, thermal. Which energy? Mechanical. Because sound waves travels in a medium. It needs medium. So it has mechanical energy. Third question. Sound is produced by vibrating molecules and therefore must have a dash in order to travel. Vacuum, medium, avenue, GPS. What's the answer? So, medium. C is the answer. As the frequency of wave increases, the wavelength will increase, remains the same, decrease, none of these. So, what is the formula? What is the answer? So where frequency increases, wavelength decreases. V is equal to n lambda. So where velocity is constant, so frequency increases, wavelength is decreases. So C is the. So let us recap the topics that are discussed today's session. So wave, what is wave? The disturbance which move. So without actual physical transfer of matter as a whole in a medium by repeated periodic motion of the particles of the medium is called wave. What is wave? The disturbance which moves without actual physical transfer of matter as a whole in medium by repeated periodic motion of the particles of the medium is called wave or disturbance created in a medium. It transports without actual motion of the medium. So only disturbance is transport from one position to another position. It is called wave. So there are two types of waves, mechanical waves, non-mechanical waves. So mechanical waves need a medium to transport or to travel from one position to another position. So non-mechanical waves need not a medium to travel from one position to another position. For example, sound waves are the mechanical waves, light waves are non-mechanical waves. So, what is sound? Sound is one form of energy which stimulates the sense of hearing. Hearing. It is a mechanical wave. Mechanical is it. How to produce sound? Sound is produced by a vibrating body. For example, when a tightly stretched string is tapped, it gives sound. And we can see the vibrations of the string. It may not always be possible to observe the vibrations of the sounding body. In such cases, if we touch the sounding body, we can feel the vibration. Hence, the source of sound is vibrating body. So, which bodies produce sounds? Vibrating bodies produces sounds. So, these vibrations sometimes we observe and sometimes not observed. So, what is the audible range of sound? A human ear can normally hear sounds of frequency ranging from 20 Hz to 20,000 Hz. So it is the audible range of human being, but it is different in different species. So for human beings, sounds frequency less than 20 Hz are called infrasonics, and sounds frequency greater than 20,000 Hz are called ultrasonics. So, the source of every sound that is heard or unheard is a vibrating body. Conversely, every sounding body is in vibrating condition that may be seen or unseen. So, how wave propagation of sound? The vibrations of sound produced by the source travel through the medium and reaches the ear. Then the eardrum vibrates accordingly and causes the sense of hearing. Sounds propagate as a wave. Sound waves are categorized as mechanical waves, which require a material medium to propagate. Sounds cannot travel in vacuum. So waves are two types, longitudinal wave motion and transverse wave motion. So what is wave? The disturbances created in a medium by the repeating periodic motion of the particles of the medium is called wave. So wave motion is the transportation of the disturbance from one place to another place in the medium is called wave motion. So waves are two types: longitudinal wave motion, the wave motion in which the particles of the medium vibrate in a direction parallel to the direction of propagation of the wave is called longitudinal wave motion. Transverse wave motion, the wave motion in which the particles of the medium vibrate in a direction perpendicular to the direction of propagation of a wave is called transverse wave motion. So longitudinal wave motion is, for example, sound waves. Transverse wave motion are, for example, water waves. So there are some differences between longitudinal waves and transverse waves. What is longitudinal waves? Particles of the medium vibrate parallel to the direction of propagation of wave is called longitudinal wave. Particles of the medium vibrate perpendicular to the direction of propagation of wave is called transverse waves. The wave travels in the form of compressions and refractions. In longitudinal wave, it forms compressions and refractions. The wave travels in the form of crests and troughs, for example, water waves. One compression and one refraction constitute one wave. One crest and one trough constitute one wave. The wave can propagate in solids and liquids and gases. So this wave means a longitudinal wave can propagate in solids, liquids and gases. Transverse wave cannot propagate in gases but propagates in solids and on the surface of liquids. This wave is one-dimensional. Longitudinal wave is one-dimensional. Transverse wave is two-dimensional. This wave cannot be polarized. This wave can be polarized. So for example, the primary wave in earthquakes is a longitudinal. The secondary wave in earthquakes is a transverse waves. All sound waves in air are called longitudinal. So water waves are called the transverse waves. So how to propagate of sound in air? Suppose consider a vibrating tuning fork. When the prongs move towards right, a compression is produced next to the prong. As the compressed layer moves forward, its compression the next layers to the right. When the prong moves to the left, it leaves a partial vacuum to the right, producing a refraction. As a result, air from the right pushes to fill the low pressure region and the position of the refraction also moves towards right during the next compression. Thus the compressions and refractions are produced alternately and advance to the right with constant velocity. These compressions and refractions follow one another as the prong vibrate and reach the ear, and the eardrum vibrates with the same frequency and causes the sensation of sound similar to the sound. So sound waves are two types: musical sound waves and noise. Musical sound and noise. Musical sound means the sounds that are pleasant to hear is called musical sounds. Musical sounds, for example, sounds from musical instruments like guitar, and the sounds that are unpleasant to hear is called noise. For examples, noise produced, sound produced by crackers, sound produced by hitting a nail with a hammer, sound produced by automobiles, locomotives, aircrafts, etc. So there is some differences between musical sound and noise. Musical sound, it is pleasant to hear, it is unpleasant to hear. The wave nature is regular, but the wave nature is irregular. Vibrations of the particles, the mediums are Vibrations of the particles of the medium are irregular. These waves will be no sudden change in amplitude. These waves be a sudden change in amplitude. The pitch and loudness are within the specified limits. There is no uniformity in pitch and loudness. Sound pulses are produced rapidly one after another. There is no sufficient rapidity of sounds. Sound from musical instruments like veena, guitar, and harmonium are the examples of the instruments produced musical sound. Sounds from thunders, crackers, trucks, etc. are the noise. Some key points where frequency is the number of waves produced in 1 second is called frequency, and it is equal to the reciprocal of the time period. So frequency is equal to 1 by t. It is measured in hertz. So wavelength is the distance traveled by the wave during time period is called wavelength, and it is denoted by lambda. So amplitude, the maximum displacement of a vibrating particle from its mean position is called amplitude. Time period means the time taken to move one wave is called time period. So what is the relation between velocity of sound, frequency, and wavelength? So velocity of sound V is equal to n lambda, where n is the frequency and lambda is the wavelength. So audible range of frequency is 20 hertz to 20,000 hertz. So it is different from different species. So I hope that you understood the topic that are discussed today. Dear students, carefully go through the lesson that I presented on waves and sound. Read the textbook thoroughly and complete the problems on the topic. I hope that this lesson is useful to you. It is clearly known that COVID-19 is spreading very fast. Take the required protection and stay home and stay safe. Don't venture outside unless it is compulsory. Thank you.